In this video, we are going to study about Euler graph. We are going to study about Euler graph. Euler circuit, Euler path and Euler graph. Again, the concepts are all linked to the same concept, Euler graph. What is this Euler graph, right? So, given a graph G, first we have to study about Euler path. First one we have to study about Euler path. Euler path in G is a simple path connecting every edge of G. Okay, Euler path in a graph G is a simple path connecting every edge of G. Okay, it means if you start from any vertex in the given graph, you start from any vertex. Is there any path where I can travel all the edges exactly once? I can travel all the edges exactly once. Meaning, if I start from in this graph G1, let's take this graph G1. If I start from A, any, you can choose any vertex. If I start from A, is there any way, any path of visiting all the edges, visiting or traveling all the edges exactly once? Okay, so if I start from A, I can go to B, I am covering this edge. From here I can come to E, I am covering this edge. From here I can come to C, I am covering this edge. Then C to D, this edge is covered. Then from D to E and to A. So, whatever edges were there in the graph, I have covered them, right? So, there exists a path. What is Euler path? Given a graph, randomly you choose, arbitrarily you choose any one vertex, and from there you try to find out a path such that you visit all the edges exactly once. A vertex may be repeated, If you see, what is Euler path in G1? Euler path of G1 is nothing but A to B to E to C to D, then to E and then to A, right? From A to B, B to E, E to C, C to D, D to E and A. See, vertex may be repeated, but you should cover all the edges at least once, exactly once, not at least, exactly once. You have to cover all those. Then we say there exists a Euler path. Next, on top of Euler path, the next concept which comes is Euler circuit. What is this Euler circuit? In a graph, if there exists a Euler path, only then Euler circuit can exist. Okay, so first condition is Euler path. Okay, Euler path exists. What is Euler circuit? Euler circuit means when you are traveling all the edges at least once. If you start at a point A, okay, if there exists a path, I am telling the definition of Euler circuit. If there exists a path from A, any random vertex A, such that if there exists a Euler path, means I am able to traverse all the edges at least once. If I start at a point and if there exists a Euler path such that I reach back to the same vertex where I started. If I reach back to the same vertex where I started, then that is called, that graph has Euler circuit. Okay, let's see this. So, let's take example of the second graph G2. Let us find out whether there exists a Euler path or Euler circuit or not. See, this G1 has both Euler circuit and Euler path. Why? See, I am starting from A, I am visiting like this and I am coming back. See, wherever I started, there I came back. So, first condition, there is a path. Second one, there is a circuit also. When we say there is a circuit, if you are starting at a point to find out the Euler path, if you are coming back to the same point, if you are coming back to the same vertex, then we say it has Euler circuit. Okay, so this has Euler circuit as well. So, any graph which has Euler circuit, okay, any graph which has Euler circuit is called as Euler graph. Okay, any graph which has Euler path and Euler circuit both is called a Euler graph. Okay, let's see this second example. In G2, do we have Euler path? First, find out path. Again, I will start from A. I can go this way, then I can come here, but if I go back, this is wrong. Why? If I go back this direction, it is wrong. Again, I have no other way to go away from here. It's like, I think you remember, we used to play some games. There are some dots on the plane. Without lifting your hand, draw some line without lifting your hand. Right? I think we remember this. Without lifting hand, visit all the vertices. Same logic here. Without lifting your hand, without repeating anything, you have to visit every edge. So if I start from A, if I come to D, okay, maybe let's check. If I come to D and then to E, then here, then this way, then this way. But from here, if I come this side, either I can go this side or I can go this side. I cannot go both the directions. So there is no path. G2 has no Euler path. If G2 has no Euler path, means there exists no Euler circuit also. Okay, right? Let's take G3. So this is not, there is no Euler path, therefore no Euler circuit also. Let's take this G3. If I start from A, maybe I will go to B, then to C, then to D, then I can come to C, I can come to A, I can come to D and come back to B. See here, I will repeat once again. See, this G3 has a Euler path. My goal is to visit all the edges. So from A, I will come to B. From B, I will come to E. So from A to B, then to E. From D, from E come to D. Okay, from E come to D. Then from D to come to C. Then comes to C. From C, go back to A. Go back to A. From A, come back to D. Come back to D. Again from D, go back to B. Right? So here G3 has a Euler path. Why? I am able to visit, I am able to travel all the edges exactly once without repeating. Some vertices might be repeated, but you are able to visit all the edges. So Euler, when the question, if they ask you Euler circuit, Euler graph, E means its focus is on edges. That way you remember. Its focus is on edges. Okay. So this G3 has a Euler path. Does it have a Euler circuit? Does this have a Euler circuit? No, because I started from A, I ended at B. So this G3 has no Euler circuit. It has only Euler path. It has only Euler path. Why? I started from A, but I ended up reaching B. Any other solution you can think? Maybe you start from B this time. Okay. So go from B to D you come, then D to E, E to B. From here you go to A. Right? From here you come to C, then you go to D, you can come to A back only. See, you started at B, but you are coming here at A. So there is no Euler circuit, but there is a path. There exists a path. So this G3 is not a Euler graph. It has only Euler path, no Euler circuit. Any graph which has both Euler path and circuit is called Euler graph. Okay, let's see a few more examples. Directed graphs also we can find out. See, if I start from A, I am trying to find out, does I have a Euler path first. Your focus is on finding Euler path. So from A I will go to B, because there is a direction, you see, there is a direction here. A to B I can go, then from B I don't have any direction. I cannot go back any side. Okay, this is in reverse order. Or even if you start from A to D, D to C, C to B, but again from B to A I don't have, and this edge is remaining. This edge is remaining. I am unable to traverse that particular edge B, A to B. So we can say that H1 has no Euler path. H1 has no Euler path. Let's see this H2. Find out whether it has Euler path or not. Right? So let me start from A. If I start from A here, let me see, from A I can go to G. From A I can go to G. From this I can go to C. I can go to C. From C I can come to B. B. Then again B to G, B to G, from G come to E, so E, again from E to D, because there is an arrow mark, I can travel that way. Then from D to F, D to F, and F to A, F to A. See, I have traversed over the entire graph. If you see this graph H2, see, I have visited all the edges of the graph. So it has Euler path, exactly once. Okay, it has Euler path. Does this have a Euler circuit? Yes. Why? Wherever I began, I came back to the same point. Wherever I started, I came back to the same point. So H2 graph is called Euler graph because it has both Euler circuit and Euler path. Okay. Next is H3. Let's see in this example, does this have a Euler path or not? Then we'll go for Euler circuit. So I will begin from A. You can start from any vertex. A to B, then from B to C I will go. Right? A to B already is covered. This is covered. I go here. Then I go to C to D, then D to B. In this path, this is not covered. This is not covered. So it has no Euler path. Okay. So this is about Euler circuit or Euler graph. Right? What is Euler graph? Euler graph means any graph which has both Euler path and Euler circuit. So to have Euler circuit, first you should have a Euler path. So this is like, no, first to find out Euler path, then check whether it has Euler circuit, then only you can confirm that it is Euler graph. So if there is a path, only then you can have a circuit. If there is a circuit, then we can say that graph is a Euler graph. Okay. So how to remember this? Euler, E means edges. Focus is on edges. I have to travel all the edges exactly once by not repeating it again. Vertices may be repeated, but edges should not be covered once again. They have to be traveled or traversed at least exactly once, not more than one. The next concept is Hamiltonian path and circuit. What is this Hamiltonian path or circuit? Same thing, right? Like Euler path, Euler circuit and Euler graph, we have Hamiltonian path, Hamiltonian circuit and Hamiltonian graph. So what is the condition here? Like in Euler graph, the focus was on edges. In in Hamiltonian path, the focus is on vertices. The focus is on vertices. Now you need not worry about the edges. What is this Hamiltonian path? Let's see what is Hamiltonian path. Okay, if there exists a path, such that I can travel all the vertices exactly once. Edges may be repeated. I can travel all the vertices exactly once. So here the focus is on vertices. Okay, you have to travel the vertices exactly once. Not all the edges need not be covered. Edges need not be covered. Only vertices have to be covered exactly once. Let's see this graph G1. Let us check whether it has an Hamiltonian path or not. See, I will start from A. I want to visit only the vertices. I will go to B. From B I will come to C. From C I will go to D. And from D I can come to E. Right? So there is a path. There is a path A to B to C to D and E. That's it. I have a path where I am able to cover all the vertices exactly once. There is a path like this. There is a road. There exists a path. I have covered all the vertices. That is Hamiltonian path. Here in this example, let's see in the G2, let's see whether it has an Hamiltonian path or not. Let's find out. See, from A I am going to B. From B I am coming to C. From C I am going to D. Yes, there is a Hamiltonian path. My focus is only on the vertices. All the vertices has to be covered. There should be such kind of a path. Okay. So this G2 also has a Hamiltonian path. Next, let's see in this G3, does there exist a Hamiltonian path? Okay, let me begin from A, I will go to B, I will go to G, I will come to E. From here, no, I can either go to C and D, but this is left over. I couldn't cover this vertex. So G3 does not have a Hamiltonian path. Okay, next, what is Hamiltonian circuit? Circuit means when you are, if there exists a path, if there exists a Hamiltonian path, if there exists a Hamiltonian path, if you are starting at a point, if you are reaching back again to the same point, then we say it has Hamiltonian circuit. See this example G1, if I start from A, I can go to B, then to C, then to D, and then to E. From E, I can come back to A again. So there is a Hamiltonian path as well as circuit. Okay, what is Hamiltonian circuit? If you in the approach of visiting all the vertices at least once, exactly once, in the approach in the solving of visiting all the vertices exactly once, if I come back to this, if there is a chance of coming back to the same point where I started, then we say it has Hamiltonian circuit. It is same as your Euler graph, Euler circuit. There we focus on edges, here we focus on vertices. So this graph G1 is called as Hamiltonian graph. Why? There exists a path and also a circuit. Let's see G2. What is the how many paths are there here in G2? There are so many paths. From A, Hamiltonian path I am talking about. From A I can go to B, I can come to D, I can go to C. See this Z shape. With that I covered all the vertices. That is the Hamiltonian path. But is there any circuit here? Let's see, from A I am starting, I am going to B, I am going to C, again to D. If I again come back, I am repeating this vertex. I should not repeat a vertex to come back to A, right? So this has, G2 has only Hamiltonian path but not circuit. It has no Hamiltonian circuit. Okay. So if you summarize what we have seen, we have studied about Euler circuit, Euler graph and Hamiltonian graph. In Euler graph, a graph is called Euler graph if there exists a Euler circuit. What is that here? Euler circuit or Euler path? My goal is to visit all the edges exactly once. And if I start at a point, after covering all the edges, if I am coming back to the same point, there is a circuit. In the same way, Hamiltonian means visit all the vertices exactly once. Ignore the edges. See, in this graph G1, when we are starting from A, we are covering only few edges. We are not worried about these edges, this one, this, we are not worried about, because that is not our goal. Our focus is only on the vertices. Okay. So remember, Euler means focus on edges, E and E is matching. The other one is Hamiltonian, focus is on vertices, right. So we will have so many problems on these graphs, Euler graph and Hamiltonian graph. Thank you.